Hello, my name is Carlos Gonçalves. I'm pursuing a PhD in Electrical and Computer Engineering. The proposed title for my thesis is Cooperative Underwater Docking with Shared Perception. For the development of this thesis, I count on the support of my supervisors, Professor Nuno Cruz, Professor Bruno Ferreira, and Professor Salviano Soares. Nowadays, several underwater robots are developed. Some of them we call it AUVs because they have the capability of execute missions autonomously. Their tasks are related to exploration, knowledge, and scientific understanding of the ocean. Then, the need arose to stay longer at the operation site, and the docking stations appeared with many advantages. For example, physical shelter for energy charging and high-speed data exchange, science requirements like readiness, long-term continuous monitoring, and bigger data sets, logistics simplification, since usually they are complex and costly, and avoid risks and hazards of typical deployment and recovery. In terms of research motivation, this work proposed several innovations regarding the state of the art. For example, transfer docking complexity from AUV to the docking station. Improve the performance of docking operation by agents' perspectives sharing. Critical information to be shared selection depending on docking agent's characteristics and the communication channel. Design a docking system capable of dock several types of AUVs. In the limit, for example, this paradigm must be capable of couple two AUVs. To drive this scientific work, three main goals are defined. One related to the study and proposal of a many different robots docking capable system. Another related to the implementation of these new docking system capabilities in terms of dynamic cooperation, instrumentation scheme, and actuation. And finally, take advantage of these docking strategies. The objectives must lead to scientific articles. Here, a working plan overview is presented, with the big blocks of the thesis work and the present position line. These blocks are curricular units work, state-of-the-art revision, creation of standards and metrics for measure the success of docking, systematize the universal docking system study on concept and requirements, the cooperative system design and development, and finally, implementation, test, and results. Regarding the curricular plan, some components are already accomplished. The thesis planning and scheduling, too, is expected to be concluded today. From the curricular units, option 1 and 2 must resolve tools for the thesis development. Option 1 subject is image processing and computer vision, with deep learning techniques application on underwater positioning and trajectory tracking based on visual and sonar images. Option 2 subject is Advanced Process Control. Here, the design and development of a model and a controller for the docking actuation model are expected. Resulting from the state-of-the-art review, some references are already identified and analyzed. Finally, I present this graphical abstract. So, there are already several AUVs and its docking system developed. In the most cases, the intelligence of docking process is more concentrated on the AUV, and some hardware support too. I propose a concentration of docking complexity in the more fixed entity, with new approaches and concept design to achieve that. Also, a cooperative paradigm development where the docking entities involved sharing each one's perspective. Finally, to provide the docking station with new capabilities in terms of actuation. The benefits of that work are docking operation performance improved, success rate increased, and new possibilities of systems interaction. Thank you for attending. I'm open to questions.